So first what I'm going to do is I'm going to do a little drawing of accuracy and precision. And if you, again, can't read this or whatever, let me know and I can switch out of drawing on the computer. But I'm going to draw a bullseye like that. And this is going to be an example of accuracy. Accuracy. And I can't write with this thing. That says accuracy, and basically accuracy refers to how close your measurement is to the accepted value or the standard. Okay? So when we did that activity outside with the PVC pipes, I kind of determined the accepted value. And I said, how close were you to my numbers? Because I got to use a ruler, whereas you guys did not. So if your measurements are accurate, they're all going to be like hitting pretty close to the bullseye. They might be like something like that, okay, around the bullseye. Okay. For precision, and I'll try to stay with my theme here of red for my bullseye. Oh, wow. I don't know about you, but I appreciate a good circle, and that was a pretty good one. So for precision, basically that's the ability for data to be repeated over and over and over again. And so even though you might not be getting close to the bullseye, maybe you're hitting like here, here, and here. Those would be pretty precise measurements. Even though they're not very close to the true value, you're at least able to repeat over and over again that you can hit that dartboard in the top right corner. Good for you, okay? You're being able to repeat those measurements. Now, if you are accurate and precise, well, they're going to have a third bullseye, and that will look something like this, and I'll just call this A and P so I don't have to write as much because it looks so bad. If you're accurate and precise, basically you're going to all be very close together in the center of that bullseye. You're hitting the true value number, and you're able to do it over and over and over again. Okay, this would be kind of like if you shoot a bow and arrow, and you shoot an arrow into the target, and then the next arrow comes and actually splits that previous arrow that's hanging on the target. Okay, you're able to just do that over and over again, which would be really cool. Okay, I'm gonna erase this. Hope that's all right. Scroll down. All right, so then we get into uncertainty. All measurements have uncertainty. It's just kind of the way the cookie crumbles, that there is some uncertainty in all measurements. And for the test, which will be on Monday, the big things that I'm concerned with you guys knowing about uncertainty is uncertainty in analog devices and then uncertainty in digital measuring devices. So let's do analog first. An analog device that I'm really concerned with you guys knowing about is a ruler. Okay? A ruler. And on a ruler, basically what you do is you look and see what is the smallest scale division on a ruler, and in our case it's a millimeter. In most rulers that is the case, that you have markings of a millimeter, and you take that scale division and you divide it by 2. So I've done that here. Here is 0.1 centimeters divided by 2 equals an uncertainty of plus or minus 0.05 centimeters, okay? Or half a millimeter if you prefer to call it that. So a ruler has an uncertainty of half a millimeter. In the video, I mentioned that all uncertainties should be reported to only one sig fig. So you can't have it like run on and be this big old long number. You should only have one sig fig, which we followed that rule in this example. Also, the uncertainty must have the same number of decimal places as the answer. So if your uncertainty is like to the thousandth place, it wouldn't work out if your answer only goes to like the hundredth place. Now here's where I made my mistake in the video if you watched it last night. Last night I talked about measuring a pencil with a ruler. And I measured the pencil, and I think I said the pencil is 4.6 centimeters long. And then I said it has an uncertainty of plus or minus 0.5 centimeters. The problem is a ruler actually has 2 readings. You have the starting reading, the 0 line, and the end reading, wherever the thing is that you're measuring to. So there's actually 2 uncertainties to a ruler. And that's kind of what throws a lot of students through a loop. So really, there are 2 plus or minus 0.05 centimeter uncertainties. And so when you have 2 uncertainties, what you do with your measurement is you add them up, and that's your total uncertainty. So 0.05 plus 0.05 would be 0.1. Okay, so you have 0.1 centimeters of uncertainty. So for the test, what I'm, and it's not going to be exactly this, but I'm going to say, let's say I measure the length of a finger. And I measure the length of a finger with just a normal ruler, one of those yellow rulers you guys were using yesterday. And I say that my finger has a length of, let's say 6.3 centimeters. What is the uncertainty of that measurement? And you would tell me, well, you have a starting point, the 0, and that has an uncertainty of 0.05 centimeters. And you have an ending point, the ending of my finger, which would have another uncertainty of 0.05. So if you add those two up, the uncertainty in this measurement would be plus or minus 0.1 centimeters. You're going to get a question just like that on the test on Monday. It won't be a finger. It'll be something else. But I'm going to tell you something is some length, and I'm going to ask you, what is the uncertainty of that measurement? What this is basically saying is my finger could be 6.3 centimeters long, but it also could be 6.2 centimeters long, or it could be 6.4 centimeters long. There's some uncertainty in that measurement, and that's what it's talking about. Okay? How does that grab you guys? Okay, it's tough, and I wouldn't lose sleep over this. Basically, if you feel like you can do this, the ruler piece and then the digital device, I'll be a happy camper. Okay, so I go into a lot more things in the video, and I'm actually going to probably edit that video and take some of it out because I think it goes beyond what you really need to know for this class. So moving on down, if we look at the uncertainty in digital devices, and I think this one's easier personally. If you look at the uncertainty of digital devices, basically you look at the smallest unit shown, and it's plus or minus that unit. Okay, and that may not make a lot of sense to you, but let's say I went outside and I ran a 40-yard dash in a miserable 8.3 seconds. Okay, which that's really bad. Okay? They called me the Jet in middle school. Okay, 8.3 seconds. What would the uncertainty be on this measurement? Well, my stopwatch goes to the 10th place. Okay, so the uncertainty would be plus or minus 0.1 seconds. So whoever, and this is taking out human error, we're just looking at the stopwatch itself. Whoever was timing me, I may have ran that 40-yard dash in 8.2 seconds. I may have ran it in 8.3. I may have even ran it in 8.4. We're not certain just because of the error in the device itself. Okay, and that's what that's saying. So on the test on Monday, I'm going to give you a temperature from a temperature probe. And I'm going to say, what's the uncertainty on this temperature? And you'll just tell me plus or minus whatever the number of digits is after the decimal point. And that's your uncertainty. Does that make sense? So here's another example. Let's say I weigh a cookie. And the cookie comes out to be, it's a huge cookie, 45.34 grams. What is the uncertainty of this measurement? So notice I have a number all the way into the hundredths place, right? Tens, hundredths place.
So it would be 0, 1?
So yeah, what would my uncertainty be? Let's say it's the test. Plus or minus 0. What?
0, 1.
Perfect. And that would be the uncertainty of that measurement because it goes to the hundredths place. Okay. So it just depends on the device itself. You know, how good of a device is it? If we used my crappy scales from my summer camp this last year, I would have had a measurement of 45 grams. The uncertainty on this would be plus or minus 1 gram. It could be 45. It could be 46. We don't really know. Okay, it could be 44. It's just that's how bad those scales were. Okay.
It's always going to be plus or minus, like with
For this, yes. Yeah. All right. On to something that I personally think is more important for the long-term success of this class is these trig functions. If you haven't had trig yet, don't worry, we'll get you caught up on the math piece, but these three things, SOHCAHTOA, are pretty important, especially for first semester physics, as we start to break things down and look at motion and forces in a variety of directions. You really need to be able to do these trig functions. So I have them just written there for you. If you think you're going to forget that, maybe put it on your note card, okay? But if you don't think you're going to forget it, well then, don't waste space on your note card with those types of things. Something that I'll give you on the test is I'll give you a triangle, and I'll say, can you find the value of theta in this right triangle? All right. So notice this triangle has all three sides labeled. right? And so you can actually use any of the three trig functions that your heart desires. It doesn't matter which one you use, cosine, tangent, or sine. It doesn't matter. So I'm just going to, just for the heck of it, I'm going to use tangent. If you want to do something different, you can. Let's see here. What would be a pretty color? Let's do blue. So the tangent of theta is equal to opposite over adjacent. Right? So here, and that's what this thing is called, is theta, by the way. So I'm sorry I didn't specify that. They call this thing theta. The opposite of theta is just look across it. It's 3. Okay, so we have 3 over, what is the adjacent of theta? It's not 5 because they call that the hypotenuse. The hypotenuse is the longest leg of a triangle, so you don't call, that's not the adjacent. The adjacent is this guy right here. It's 4. Okay, so you have 3 over 4. So in the end, it's tangent theta equals 3 over 4. Now that's not the answer, right? That's not the angle that you should be getting. How do you get the angle? Does anyone know? Perfect. So in the end, this is going to look like theta equals the inverse of tangent 3 over 4. Okay? And if you plug that into your calculator, and that's really what it is, it's just calculator work, I get a theta of 36.9 degrees. And I encourage you to try this, with your calculator. Make sure you're able to get it. In my second hour, I had 2 or 3 students who had their calculator in radians over degrees. You need it in degrees. If you have it in radians, you're going to get a completely different answer. And that's another one of those, what I call stupid mistakes, because you did everything right and your calculator's just in the wrong mode. That's a real bummer because you're going to get totally the wrong answer, and there's just not much you can do about it. Okay, so I hate for you to spend all this time on a problem, like 10 minutes working a problem to finally get to the answer, and the whole time you've been in radians and you're using the wrong numbers. Okay, so just make sure you can get this stuff. If you can't, let me know. I can try to help you with calculators. I'm not a calculator master, but I can see what I can do. All right, one more, and then we're off to the races. So I've got this triangle here. Notice I know 2 sides, and I have a side labeled A, and then there's theta. Okay. I'm going to first find theta, but there's really no reason why you have to find theta first in this example, but I'm just going to for the heck of it. What would be a good trig function for finding theta? So the sine, that's right, is opposite over hypotenuse. Okay, this is the so piece. So what is the opposite of theta? Be 11. And the hypotenuse is 15. Okay. So in the end, I'm going to write sine theta equals 11 over 15. Now that's not the answer. I need to take the inverse sine of this. So I have theta equals the inverse sine, whoops, there's supposed to be 1 there, 11 over 15. And if you do that math, I get theta equals 47.2 degrees. And again, I encourage you to at least try this to see that you're getting the same numbers as me. If you're not, we got to figure something out, like what's going on with your calculator. Okay. Now, to get side A, you could absolutely use your trig functions if you want to. If there's no reason why, now that you know that theta piece, you could absolutely get A by using, the sine, the cosine, tangent, all that good stuff is fair game. But I want to show you the Pythagorean theorem in terms of doing it that way. So the Pythagorean theorem basically says A squared plus 11 squared, or B squared in theory, but this is the B, equals C squared, which is 15 squared. I basically want to get A squared by itself, so if you do a little algebra and you take this 11 squared and bring it over to the right-hand side, you get A squared equals 104. Right? Well, that's not quite the answer. I'm going to take the square root of 104, and I get A equals 10.2. And that was my answer for A.